So we're going to start talking about solutions today. There's some vocabulary that you're going to need for this unit that we're going to start off with some visuals to help explain what exactly you're looking at. So first off, before we get too far into this, what is a solution? So a solution is a homogeneous mixture of two or more substances in a single phase. So if you take a look at the beaker on the left, you can see that you have a blue solution. We don't really know what the solution is, but we know it's equal throughout. There's not any areas that are more blue or more clear than others. There's no solids that appear to be floating. There's no precipitate. So this would be a great example of a solution. In the second example here, we have this white precipitate that forms. So in a solution, we can have a precipitate form. However, the precipitate isn't something, it kind of breaks the definition of a solution. We no longer have that. We'll have a heterogeneous mixture or just a mixture. So we have a few vocabulary words that we need to know. A solvent. This is the substance that does the dissolving. This is the substance that's present in a larger amount. The solute is the substance that's dissolved. So the solute can be a solid, but it also could be a gas or even another liquid. It's usually a solid, but not always. Solvent, think of the universal solvent with water. That's something that we use a lot for our solutions. So that's something to keep in mind. So then, kind of going back to Unit 5 where we were talking about reactions, we have the term soluble versus insoluble. So when something is soluble, what that means is you're able to dissolve it. So you are able to dissolve it within the substance. So if you think of sugar and water, you're able to dissolve it. Salt and water, you're able to dissolve it. And when something's insoluble, that's when the substance cannot be dissolved. This is when you form a precipitate. And if you have a reaction that forms an insoluble substance, that gives you a precipitate. And then an alloy is a solution containing two or more metallic elements, as discussed. So here we have sugar water. So in a solution of sugar water, the solvent is the water, the solute is the sugar. Okay. So then we have these terms miscible and immiscible. It's similar to the idea of soluble and insoluble, but more specific. Miscible refers to two liquids, and so if they can dissolve, it's referred to as miscible. If it's immiscible, that's when they don't mix. So you have clear layers. So here we have a solution of water and methylene. So we have this clear layer between them that makes the solution immiscible. When we mix the two solutions together, such as acetone and water, you can't tell where they are, so that would be miscible. And then also aqueous solutions. These are solutions where the solvent is water. Okay. So, concentrated versus dilute. So when you have something that's concentrated, that means that the solution contains a large amount of solute. Dilute is when it contains little solute. So here I have an example of a red solution. So the dilutest, or the most dilute sample here is the light red, while the most concentrated is this dark red, almost black. So concentrate, this is relative. You usually are comparing multiple solutions, so you would refer to one as the most concentrated or the most dilute. There really isn't a number that you use to associate it with. Okay. Saturated, unsaturated, and supersaturated. So, saturated means a solution that contains the maximum amount of solute. So if you're thinking of a bridge has that maximum amount that it can hold. It's the same idea. So it's the capacity of the solution to hold a certain amount of solute. Every solution and every solute has this saturated level. Unsaturated means the solution is below that maximum amount. And then we have supersaturated. Supersaturated isn't something that just happens if you add salt. You kind of are essentially, I refer to it as tricking the solution. So this is when it contains above the maximum amount. This can only happen under certain circumstances, which we'll get into in a little bit. Because you have to, in order to have a supersaturated solution, it usually involves a temperature change where it can hold more, and then you change it back to the original temperature, and it makes this kind of unstable solution. So saturated versus unsaturated, if we had a solution that was unsaturated and we tried to dissolve more solute, it's going to dissolve readily. It's not going to be a hesitation. A saturated solution, if you add more solute, it means it's not going to dissolve. It's just going to sit on the bottom. And then a supersaturated, if you add more solute, what's going to happen is a rapid crystallization, forming crystals in the bottom, kind of started from the crystals added. Okay. One of the things that we're going to look at here is we're going to look at the rate at which a solution is formed. So the first thing is the surface area or the particle size. So the more surface area, the faster the solution will form. I.e. the solute will dissolve faster. So think of an example of a sugar cube versus granular sugar. In the olden days, you used to add a sugar cube to your iced tea or your coffee, just because it was a little bit easier and more sanitary. However, if you have the sugar cube, the solution can only dissolve on the outside. So it can only come in contact with the outside of your sugar. If you have granulated sugar, you're exposing more of the solute to the solution, allowing it for it to dissolve faster. Temperature. So for temperature, so for solids, generally speaking, if you increase your temperature, it dissolves faster. The reason this happens is the particles are moving more quickly through the solution, allowing them to come in contact with more of the solute particles. So the opposite is true for gases. For gases, you actually need to lower the temperature to dissolve faster, or to be able to have a higher capacity, however you want to say it. Let's say higher capacity here. Okay, so think of soda for a moment. Have any of you ever poured soda onto ice cubes? What happens is a lot of the soda fizzes and you lose a lot of the carbonation. However, if you store your soda in the refrigerator and then pour it onto the ice, you're going to see a significant amount less of the foaming. So the lower the temperature is of your solution or your solvent, the more gas it can hold. So soda is a great example of this because it is something you've seen before. The lower you have the temperature, the better, or the more carbon dioxide it can hold. So the last thing here is agitation. This is kind of common sense. If you stir a solution or you shake a solution, it will dissolve faster. So agitation would be stir or shake to increase the rate. Now the way that I like to think of this, or the way I remember, is I like to think of making an iced tea. If you've ever ordered an iced tea that you didn't realize was unsweetened and you try to add sugar at the restaurant or wherever you are, there's 3 things you can do to make your sugar dissolve faster. The first thing, which you're probably going to do, is stir it. The second thing, if it's a sugar cube, you would smash the sugar cube to give you more surface area to dissolve it. And then the third thing, if you warm your tea a little bit, so maybe you put your hands around the iced tea or you have some other way of warming it, you'll be able to again dissolve it. If you've ever had like the super sweet iced tea, or southern iced tea sometimes it's called, When you make it, when you add the sugar while it's still hot, so that way it will dissolve. Otherwise, it won't dissolve easily into your solution, and you'll have the little pieces of sugar stuck on the bottom.